Welcome back, Smart Contract Maxis. And in previous part we built this EIP 2612 smart contract, and in this part we are going to test our smart contract from scratch, and we will in next part we will deploy it on chain on the Sepolia network. So let's get started. And you can see here in previous part we created this permit token smart contract, and we understand what is EIP 2612 by going through this charts. So let's get back and let's start testing our smart contract. So for that, let's create testing file permit token test.t.sol. Oh, it's there. Let's rename it permit token t.sol. And here we go. Let's start with not here pragma, and the license identifier is MIT, and we are going to use the same version. So let's copy from here and let's paste over here, and let's start importing test and console. And for so let's import permit token or smart contract from /src slash what's wrong. We added permit token dot sol. Is it? Yeah. Now let's import test and also console from for standard library and slash test dot sol. There we go. What is the callback not supported? This is VS Code error. So let's permit token test contract permit token test is test, and let's go and let's declare our internal variable here first. Internal, let's name it token, and we have to declare 5 variables, or owner private key, spender private key, owner and spender, and a recipient. So let's declare one by one first. Let's make everyone internal, and owner private key, and let's say 0x let's say 111 A11 and CE. There we go. Now int 256 and internal, let's make it spender private key, spender private key, and let's initialize it with 0x b0b or something like this. You can keep it anything. Let's address of internal owner, and we are not going to initialize it owner here. And let's copy, let's paste below, and spender, and also we need a recipient, right? Recipient my spelling mistakes. Now go below this, and we need two constant variables, uint 256 internal constant initial supply, let's say 1 million initial supply, let's say 1 million ETH, or the ether, and also we need bytes 32 bytes. I'm making a lot of spelling mistake. Internal and constant. Let's name it permit type hash. Permit type hash type hash is equal to, let's take a 256, and inside that let's pass permit and address of the owner, address of the spender, 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 then value you int 256 value, then we need to pass nonce you int 256 nonce, also we need to pass deadline you int 256 not 255 deadline. There we go. And these are the our variables. Let's format this and make it beautiful, and that's it. Let's go for our main setup function. There we will initialize our owner, spender, and recipient, as well as the token we declared over here. So let's set up function setup, and we are going to use some Foundry cheat codes over here. We need to make it public. If you have watched my previous tutorials, I explained how we can test and why we have to make this public. So let's initialize owner. Owner is equal to, let's say, cm dot addr, and inside that we need to pass owner private key. That's it. And spender, spender is equal to cm dot addr, and spender private key, and beneath this recipient, let's initialize with this recipient is equal to make addr, and let's pass recipient over as a string, and token is equal to new permit token, and we have to name it, let's name it permit token only, permit token, and the symbol is like permit token. Oh, I'm making a lot of mistakes over here. Symbol is like pmt, and we also need to pass initial supply and owner. So initial supply we already declared here, and the owner. And that's it. Our function setup function is ready, and now we are good to go. So let's first test metadata and supply if everything is going good. So for that, let's create a function test. So your test function, in testing whatever you are testing, your function should always start with test. So test metadata and supply, and supply, let's make it public view, and go below this and use this assert equal, and on the left hand side token dot name, and on the right hand side we need to pass this name that we set up over here inside the string. Okay, that's it. Now assert equal on the left hand side token dot dot symbol, and on the right hand side emt, right, and assert equal token dot decimals, and how much decimals we have? 18, because it is also ERC-20. Now assert equal token dot total supply, and here we need to pass initial supply. Assert equal token dot balance of, and in account we need to pass owner. There we go. And here we need to pass the initial supply, and that's it. And let's test forge test, and you can see here our first test is passed. Now what we have to do is we need to test the permit set allowance. So let's start testing permit set allowance. So let's create a function test permit set allowance. Let's make it public and go open the body of our function. So before that we need to create an internal function for sign permit, because that we are going to use in our function. So let's create this function first. Function sign permit, and let's make it internal view, internal view, and it will returns fee or yes, that I explained in the previous video. So let's return, but before that let's take parameters. Int 256, it will take private key, it will also take permit owner, address of the permit owner, it will also take address of the permit spender, it will take value nonce and deadline. So let's do this one by one. Value 56 nonce, also deadline int 256 deadline. Now let's return from here, returns event 8 of p bytes 32 of r and bytes 32 of yes. So we are returning phi r yes from here. Now inside that inside our body, let's take bytes 32 of struct hash. Let's name it struct hash hash and is equal to kckup 256 and inside that let's pass abi dot encode and here we need to pass permit type hash, permit owner, permit spender. We need to also pass value and nonce and deadline and and that's it. Now go below this and let's take another local variable of bytes 32. Let's name it digest and let's take it kckup 256 abi dot encode packed. This time we are going to use and arguments we have to give you over here is this is very important, so pay some attention here. We are going to pass inside the string slash x19 and again slash, it is not slash, I don't know what it is, 01 and now again we have to pass token dot domain separator from here and struct hash that we created, struct hash, right? And that's it. Now go below and take phi res. Oh, I forgot the comma. Phi res is equal to pm dot sign and we have to pass the private key and digest. That's it, right? Now we can use this function over our testing, for our testing anywhere. So let's start with permit transfer form. So here we go. Permit set allowance, not a transfer form. We will test our next function. So let's take here a variable as in value of 100 ether. So let's start event 56 value of, let's say 100 ETH or 200 ether and not ether. Let's take another variable of nonce, even 256 nonce is equal to token dot nonce nonces actually and the owner, right? And deadline event 256 deadline is equal to block dot timestamp, the global variable we are going to use, plus 1 ether, 1 days, not an ether. Now let's go below this. Event 8 taken fee, event 8 of fee and bytes 32 of R, and again bytes 32 of yes, right, is equal to, now let's use our this sign function. We created sign permit, and we have to pass sign permit. Inside that we have to pass owner private key, owner spender, value nonce, and deadline value nonce and deadline, and that's it. Go below this because it is taking these 6 parameters. We are passing these 6 parameters over here. Now go below this and let's assert equal, and on the left hand side token dot allowance, and inside that owner and spender, and on the right hand side it should be 0, right? Now let's go, and if anyone can submit the sign permit, for that pm dot frank, and inside the frank the message we have to send is relayer what is wrong, member prank found visible lookup in the contract VM. Oh, we forget here, make addr VM dot frank, and inside that we have to pass make addr, and inside that we have to pass that relayer, and that's it. Let's go below, and token dot permit, and we need to pass owner spender value deadline and frs. It takes right, it took right, and now assert equal, on the left hand side token dot, oh, let's copy this and directly paste over here, token dot allowance to owner spender, and we have to pass not 0 this time, we have to pass value. Go below this and again add another assert equal here, and token dot nonsense, not nonsense, it's token dot nonsense, and owner is right, and on the right hand side we have to pass nonce plus 1. That's it. Let's format, and you can see, let's test forge test. So you can see our second test is failed, and ERC valid signature test something. What is this? Forge test, not forget, forge test dash vvv. To see the traces over here, it is returning us this, then reverting this, and this. Oh, something is wrong. We will fix this later. Let's go ahead and let's permit then let's add another test over here, which is our last test, and you can add as much test as you can, but let's first test revert when replay permit. You can add test revert when invalid signature, or test revert when permit expired, or permit transfer form. So we are going to add, let's add only like one test for this, and let's check. I will debug it and I will give entire source code in the description of correct test. So function, let's add our last another function, test revert, test revert when invalid signature, invalid signature. Let's make it public, and let's take an variable event 256 of value, and we took, I think, 100 ether. Let's take here only 1 ether and go below this. And nonsense, we need to, we need to copy this and this also. So let's copy this, let's go here, over here, paste. I think we need this function above this signature function, sign permit function. And let's sign with spender's key instead of owner. Okay, let's try signing. So let's take it the same behavior from, not from here, where it is, yeah, same. Copy this from here, and let's take event spender private key instead of owner private key. Let's pass spender private key, owner, spender value, nonce and deadline. And here let's use vm dot expect revert, and here token dot permit, and you can see here it automatically took owner, spender value, deadline, and VRS. So let's test. I have to debug it for test. Let's see. Yeah, to test fast succeed. Can we write another test, one more test over here to check if everything working? Let's test our this uh, domain separator. So let's write another function here, function test of test uh, domain separator. Let's copy this domain separator from here and paste over here. Let's make it public and go. We also need to make it view because we are not going to modify any state. So let's take an local variable here, bytes 32, and expected is equal to let's add kcc 256, and inside that abi.encode, and here we need to add a lot of data. Again, inside that abi.encode we need to pass kcc 256, and inside that kcc 256 we will add EIP 712 712 domain, and let's add string of name and string of version. Let's also add chain id uint256 chain id we also going to add verifying contract. So address of the verifying contract. Now we from here we will add another kcook 256 here, kcook 256, and inside that we need to add bytes 32. It is complex, yeah, indeed it is complex. It will not make sense, but it will make sense. Token dot name, right? And from here we need to pass again another kcook 256, and inside that let's pass bytes only, and let's go inside the string 1 and block dot chain id chain id and address of the token. Let's see. We need to add this here, over here. And what is this error? It is giving us error over here. What is this error? Explicit type cannot string memory. Kcook 256 bytes. Yeah, it's byte, not bytes 32. And now go below this and let's assert equal, and on the left hand side let's pass token dot domain separator, and on the right hand side we need to pass this expected what we have created over here. Let's format the docs and let's test for test and 2 failing test. So we return 4 test and 2 already failed. So I will trace this out, forge test, and I will debug fee, and it is giving us the static call setup, and it is reverting over here. So I will debug it and I will come back in the next video. I will give you entire source code of this test, and I will also explain where our tests were failing. So with that I am closing this part of this testing part, and I will see you in the next, where we will deploy our smart contracts. I will show you entire test, and where we are like. So bye bye, I will see you in the next one.